Hello and welcome to our 19th annual exhibit of hydrogen and fuel cell technology. We've been here since 1995 discussing what will be the future of our energy system. And in the following discussion, we'll be talking about a big player who's helping us to get this technology marketable, advancing its potential. Namely, we'll be talking with Oliver Wudtke, who is the Sales and Purchasing Director from Busch Clean Air. Please welcome with me Oliver Wudtke.
Thank. So, hello to everyone.
Good morning. So whenever we have a big player who comes from outside the fuel cell industry and comes into the fuel cell industry and help us out, the first question is, Busch as opposed to Busch Clean Air, it's a large company.
Yeah, that's right. Yeah.
Tell us a bit about the company and how it made this transition.
So Busch is coming from vacuum industry, vacuum pumps, systems, compressors and blowers, and a family-owned company. So we have this year our 50th anniversary, and we used even to be one of the largest manufacturers in this field. So we started the business of Busch Clean Air itself because of the request of the automotive industry. Yeah. So Busch in general is very involved in industrial applications, never worked with automotive industry and its special requirements. So when they have been asked by some big engine makers or system makers, they have been asked to develop solutions for exhaust gas after treatment. So they used one of the different technologies existing within the Busch Group. We are speaking about rotary claw pump compressor, or which is also used for vacuum solutions. They used this one and they downsized it for a mobile application, knowing that most of the applications within the Busch Group are not mobile applications, so stationary. And now the challenge was to bring it to a small size and to make it even very robust. So we worked on this target, and the first application we have been asked for was for an exhaust gas after treatment to combine air supply with an active regeneration of a diesel particulate filter. So the challenge was to have a system which have a high efficiency, which is very robust, which has also a low consumption and a long lifetime. Something which is standard in automotive industry, but not every time in general in the industry itself. Busch had one solution in a big size. So I already mentioned the rotary claw pumps. And after several discussions with the customers, they decided to go on this technology. And so, yeah, we built our first pump. This is this one here. Yeah, I can show it to you. This used to be, and this is already a big series. This used to be for the active regeneration of a diesel particulate filter in combination with a burner. This one is used for off-highway applications which don't have any onboard compressed air like a truck or whatever. So we speak here about applications in mining applications, trains or whatever. This was how we started the business at Busch Clean Air. So this is, as I mentioned, already in serious production since 1 year. So we already produced 15,000 of those pumps. This means that we are able also to make mass production. This is something very important, something new within the Busch Group, yeah. Because Busch Group is very specialized in special applications, and yeah, they decided once to create Busch Clean Air, and this is now our company where I'm coming from, Busch Clean Air in Switzerland. So we have our plant in Porrentruy, which is not far from the French border, where we have also a big automotive industry. in the area of Montbéliard and Mulhouse. And so we carried over the know-how from the Busch Group in terms of pump technology and the know-how in terms of automotive industry. By hiring people coming from automotive industry, we brought it together in the company Busch Clean Air. Yeah.
So you've essentially, in cooperation with the automotive industry, developed a new series of expertise extending beyond the industrialized experience. When this sort of synergy happens, you have pump technology. One always asks the question, did the clients from the automotive industry come to you? Did you think, just a minute, we can shake this up and it still works, so it's good for automotive? How did that process take place?
So, in fact, you don't have, as a robust or technology with a long lifetime, you have not so many pump technologies on the market. Yeah, you have a lot of automotive applications already existing, but if you speak about lifetime, in this case, we can guarantee a lifetime of 15,000 operating hours. And this in a temperature range from minus 40 degrees up to 85 degrees. This is coming from the application, and there you already have a selection of the possible technologies. So, on the other hand, so this was an existing product, as I mentioned, within the Busch Group, but in a big size. Now the challenge was to make it small, and we achieved. And as we have now a product available in this size, we even developed a smaller one. This is for another application, automotive industry. This is for the AdBlue injection, which is a urea injection for SCR. SCR is a denox reduction within the exhaust gas system. And this is another challenge we have now. So we developed a medium-sized one and a small one. And this on request of the automotive industry. So what happened now? Why are we here? It's because we, of course, we have something which might be also dedicated for fuel cells. Especially as an overpressure technology for the fuel cells for the air supply. And when we made our calculations in terms what might fit to a fuel cell, we have found out that also our product is it fits also to this application. With the advantages we already developed, which are already validated, which are already in series. As robustness, as temporary range, as different altitudes. We can use it in altitudes from minus 1,000 meters up to 4,000 meters. And we have a speed regulation, so we can guarantee always the same volume flow. We have, this might be very important for you, we can achieve overpressures with the range. We have this type of pumps up to 2 bars. Absolutely.
So you're actually, right now, even beyond the needs of the fuel cells. There's very interesting issues here. When we talk about the PEM cell, I like to refer to the PEM cell as the fussy member of the fuel cell technology, because it needs a steady flow of gases, it needs that liquefaction, it needs to be wet all the time, it has very specific temperature parameters, and when you mention temperatures up to 85 degrees or minus 40, well, gee, that's well beyond what PEM cell operating temperatures tolerate. But the other issues of absolutely reliable, constant, scalable flow, things like that, that's very important. So are there specific challenges that the fuel cell industry had, and they came to you and they said, you know, this is exactly what we need?
So in fact, one key is the overpressure. Combined, of course, with the volume flow. So we are able today to serve with our small pumps. You can see on our booth here. We can serve fuel cells from 1 kilowatt up to 15 kilowatt. But we have, this is for mobile applications. If we go further, if we take the big ones, we have, within the Busch Group, we can even go up to 150 kilowatts.
There's a number of issues here. We're already talking about mobile applications in this case. Stationary applications have less restrictions of space. They have less restrictions in other aspects as well. Vibration is not a factor. So are there specific, I've seen a number of people offer DC brushless motors, all sorts of different facilities for doing pumping activities.
Yeah.
Are there specific challenges, again, for the automotive sector of PEM cell applications, where you're very unique? You have a rotary vane pump, you have a rotary claw, a screw vacuum pump, you have these specific technologies. So what is the cutting edge there? What is the sort of the added technology advancement?
Yeah, I would say in this case, it's of course the lifetime. Yeah, that's very, and we have a very low consumption, energy consumption. If we produce energy, we don't want to have a consumption on the side of our air supply. So we have a big efficiency, and something very interesting in this case is also it's oil-free, it's contact-free. Yeah. Yeah, but also the advantages we have out of this technology. Yeah.
But these are significant, of course, because the PEM cells, they kind of, they don't like any impurities whatsoever.
Yeah.
So very significant. In terms of efficiencies, I think this is a central issue because, well, actually the two, efficiency and lifetime. PEM cell manufacturers who are thinking automotive, they think anything below 15,000 operating hours is kind of, it's not going to compete with a conventional combustion engine, and it's expensive.
Yeah.
So it has to get beyond 15,000 hours, and I think the end goal would at some point reach 20,000. So there's that life scale, and the other thing is the efficiency. For you, what is the greater challenge?
Yeah, to bring the overpressure, of course. Yeah, because we're working with very tough clearances, and we even think that we can go better. But at the moment, as I already mentioned, we have to cover a temperature range from -40 up to 85 degrees.
Yeah.
If this temperature range is even limited, we can make it better in terms of clearances and go even better in terms of overpressure. There is even we have still some space to optimize the products. Yeah. For the moment being, it's optimized for automotive applications. If we can bring it to the fuel cell, we can even do it better in terms of overpressure. Yeah. Yeah.
Okay. We're in a transitional phase in the entire industry, at least in terms of applications. The applications are being tested. No one is industrialized an automotive solution, a fuel cell car that can be mass produced. But times are changing, the energy market is changing. So in this stage, there are a lot of people still involved in research and development who have viable products. They need to cut costs, they need to increase efficiency, and they really need to go to specialists who produce the components surrounding the fuel cells. Are you interested in getting involved in this dirty work of having someone from the fuel cell industry say, I'm an engineer, we've developed this product, but it won't work with all the infrastructure, and the power consumption surrounding this fuel cell makes it inefficient?
We see two paths we have to follow, with two different speeds also. One path, of course, is research, and we are partner for research, especially what's regarding the air supply. We have the competence, we can do calculations and whatever is necessary. On the other hand, we are already ready for production, because we have an existing product which can be adapted easily to a stack or whatever, so we can go on with production in a short term. That's no problem, and we have already the production facilities, assembling lines, and whatever. So we follow two paths, but we are open for developments and research, of course, but already for production as well.
Okay. Whenever we address this sort of last question in a series of questions, there's this fundamental question of motivation. People who get involved in this industry are not necessarily involved in the industry because today or tomorrow there's going to be an increase of revenue. it's largely, or very often, a sense of getting involved now gives you an edge on future development. But you need to be then convinced that there is going to be an increasing size of market here. So it's a question to you, philosophically speaking, when one looks at the energy market available and the transportation market, are you convinced that there is going to be a future for the fuel cell industry also in the automotive sector? Is this part of your motivation in getting involved?
Of course. The market will be developed soon, but step by step. Yeah, we know. I think it's depending on some important key players, which will make the first step to go in mass production. And once we are in mass production, it will be very fast. What we have seen, especially in automotive industry, is now that they build some consortiums. So this is very important, to focus together on mass production and to go ahead.
I've seen a gentleman from the audience has a question here. It is open, it's a public forum, so questions from the audience are welcome. Hello, sir.
Thank you very much. My name is Dabo Ogumoyiwa. I'm an automotive consultant. You said that your components would be competitive for the automotive industry with 15,000 hours. That is on the assumption that your fuel cell powertrain is competitive in price with the internal combustion engine. If it costs 3 or 4 or 5 times more, then we'd naturally expect a much longer lifetime for the cost of ownership.
What I can say for the total cost of ownership, it's very important to have a long lifetime. That's for sure. And on the other hand, it's also very important to have a low consumption, energy consumption, besides the motor. And I would say that this technology has the advantages we can offer to the automotive industry.
Have we run out of questions here? Because we've really run out of time. But the conversation, of course, should be continued. You can join Oliver Wudtke. He's at D70, so it's just around the corner here. And continue the conversation. We've been talking with Oliver Wudtke, who's Sales and Purchasing Director from Busch Clean Air. And it's been a pleasure to have you, a specialist in your field, and hope to see you back next year.
Thank you very much.
Thank you, Oliver.
Thank you.